Hello everyone, the content we will learn in this course is welding stress and deformation. The course content of this section mainly includes 1. Basic knowledge of welding stress and deformation. 2. Reasons for welding stress and deformation. 3. The classification of welding stress and deformation. The first part, the basic knowledge of welding stress and deformation. 1. Deformation under the action of external force or temperature and other factors. The shape and size of an object change, and this change is called the deformation of the object. Elastic deformation. When the external force or other factors that deform the object is removed, the deformation also disappears, and the object can be restored to its original state. Plastic deformation. When the external force or other factors are removed, the deformation still exists, and the object cannot be restored to its original state. 2. Stress. Internal force. The resistance that exists inside the object and is caused by external force or other factors to cause deformation of the object. Stress. The internal force per unit cross-sectional area of an object. According to the different causes of internal force, stress is divided into working stress and internal stress. Welding stress is an internal stress. The salient features of internal stress. Inside the object, the internal stress is self-balancing, forming a balanced force system. 3. Welding stress and welding deformation. Welding stress. The internal stress that exists in the weldment during and after the welding process. Welding distortion. The change in the size of the weldment caused by welding. Welding stress and deformation are often unavoidable in the welding process, which affects the dimensional accuracy of the welded structure and the strength of the welded joint. Therefore, in the welding process, the welding stress and deformation should be reduced as much as possible to ensure the high quality of the welded structure. The second part, the cause of welding stress and deformation. The picture shows the stress and deformation caused by heating in the center of the long strip. 1. Uneven heating of weldments. The welding of weldments is a local heating process, and the temperature distribution on the weldments is extremely uneven, which is the main reason for welding stress and deformation. 2. Shrinkage of weld metal. When the weld metal cools, it is liquid to solid and shrinks in volume. The weld metal does not shrink freely. This will cause deformation of the entire weldment and at the same time cause residual stress in the weld. A weld is formed gradually, and the first crystallized part of the weld should prevent the shrinkage of the later crystallized part, which will also produce welding stress and deformation. 3. Changes in metal structure. Steel undergoes phase transformation during heating and cooling, and different structures can be obtained. The specific volumes of these structures are also different, which will also cause welding stress and deformation. 4. Rigidity and restraint of weldments. Rigidity is the performance of the weldment itself, which is related to the material of the weldment, the shape and size of the cross-section of the weldment, etc., while restraint is an external condition. The greater the rigidity of the weldment itself and the degree of restraint by the surroundings, the smaller the welding deformation and the greater the welding stress. On the contrary, the smaller the rigidity of the weldment itself and the degree of restraint by the surroundings, the greater the welding deformation and the greater the welding stress. The third part, the classification of welding stress and deformation. Welding stress can be divided into the following three types according to the reasons for its formation. 1. Thermal stress, during welding. The stress caused by the uneven thermal expansion of each part of the weldment due to uneven heating. 2. Microstructure stress, during the welding process. Due to the different thermal effects of each part of the weldment, different metallographic structure transformations occur in each local metal. And the volume changes will occur with the metallographic structure changes. When the volume change is blocked tissue stress. 3. Condensation stress. During welding, as the molten metal pool condenses from a liquid state to a solid state, the condensation stress is formed when its volume shrinks. Classification of welding deformation. During welding, various forms of deformation will occur due to the influence of factors such as the form of the welded joint, the thickness of the plate, the length of the weld, the position of the weld and the shape of the structure. The basic forms of welding deformation include shrinkage deformation, angular deformation, bending deformation, wave deformation and twisting deformation. 1. Shrinkage deformation. The phenomenon that the size of the weldment is shorter than that before welding is called shrinkage deformation. It is divided into longitudinal shrinkage deformation and lateral shrinkage deformation. 2. Angular deformation. During welding, the rotational deformation caused by the uneven lateral shrinkage of the welding area along the plate thickness direction. The pictures show the angular deformation of surfacing butt joint and T-joint respectively. The bending deformation is caused by the misalignment or asymmetry between the center line of the weld and the neutral axis of the structural section. And the shrinkage of the weld is unevenly distributed along the width of the component. There are two types of bending deformation. One is bending deformation caused by longitudinal shrinkage, and the other is bending deformation caused by lateral shrinkage. Wave deformation often occurs in the welding process of thin plates with a thickness of less than 6 mm. Also known as buckling deformation. Large area slab splicing, such as hull decks, large oil tank bottoms, etc., is prone to wave deformation. The figure shows the twisting deformation of the I-beam. The reason for the twisting deformation is that the angular deformation of the weld is unevenly distributed along the length of the weld. Influencing factors. Distortion deformation mainly occurs in slender welded components. These components generally have long longitudinal fillet welds. Due to improper assembly or incorrect welding sequence and direction, the corner deformation of the weld is uneven along the length direction, causing twist-like deformation. This is the end of this lesson. Thank you for watching.